Mario Like series. In this part, I'll try to do some UI work, collectible items, and what else do we have? Some enemy movement to get things going. For starters, we will add a simple UI canvas, and we'll just set it to scale with screen size. And we will add, so what do we want to have for our game? We want to have I guess we want to have a text which is going to display our points. And we're straight away going to change from Arial to our font that we found. So this is going to be text layer points. We're going to show the player which level we're on, so we'll just type in text current level, as we will have few levels just like in Mario, and then we will have health. For now we will display health as text, but later we will change that to some kind of a little UI display, so we'll just call it player health. Now that we have this, let's just attach each of these sections in their appropriate screen positions. So let's place the health at top left, the current level in the middle, and points in the top left of the screen. I'm going to select the best fit for both of them, but for all of them, in fact, I want them all to be 18 and minimum at 10, which is fine. Let's make them bold, and let's make them move slightly. For this one, we'll leave it in the center. This one can stay here, but the other one will go all the way to the end. So our points will be written like this. We'll have points, and let's just put like a number. We probably want to have a slight offset from the left. So let's just do a -5 here, and just do a +5 here for the health. So we'll just type in health, and we'll just set it 3 out of 3, like so. Level. I don't remember how Minecraft does it. Let's just leave it as 1/1, and then we can have whatever else that we will have. With this done, let's start coding everything in. So let's go into our, do we have a game manager script? No, we don't. Okay, so let's set up the cylinder tower as well. Or actually, let's just disable them as we're not working on them just yet. And now what we have here, flag object is here, that's fine. Let's create an empty game object, reset, and call it the game manager. We'll put our game manager at the top of our scene, and we'll attach our game manager game object in here. Now that we have our game manager open, like we said, we want to store some information about our level. So first thing we want to do is we want to make sure that our game manager is an instance. So we'll do public static game manager instance, and then we'll use awake function, and we'll just do instance is equal to this. And what we'll do is if instance is equal to null, then we're going to make else, and then we'll do else if instance is not null, destroy this. So what will happen is, let's just declare the game object. If our instance is null, then that means that this is the first level that we loaded that contains a game manager script, and that means that we set it to this instance. However, if we loaded a different level, we want to carry over all of our information, so we will just destroy this brand new instance and keep the old one. And we'll finish this by adding don't destroy on load. And of course, we'll put this not game object. So this will allow us our game object to travel between different scenes without being destroyed. And that's done. Now, with instance done, we'll then need to store in all of our level, health, and points information. So let's create a header and just call it text elements. Or actually, we'll create our text separately. We'll just store the values here. So let's create a private float or integer points, private integer health, and private integer level. Or will we store level like this? Or let's just keep it as a string like this. Now now that we have this, let's create a new class for handling UI. Do we have a UI class? No, we don't. So let's create a new class. We'll call it the UI manager. Now, the reason why we're going to separate the text from the game manager is because we would lose the connection between this specific canvas and our level every time we would change the scene, and that's not something we want to do. So let's add our UI manager. What's wrong? Oh, that's right. Let's add the UI manager in here. Edit the script. Just remove these, and we will use Unity engine.ui like so, and we'll create 3 serializable text components. First is going to be our player health, which we will replace for an alternative display later on. So we'll have our health, we'll have our level, and finally we will have our point display. Now, what we'll essentially do is create 3 functions here, and one's going to be update player health. Next one's going to be update the game level. And finally, we'll do public void update points gained. Like so. Now, player health will display what we have here. So we'll at the top, so we'll have health, a little space, and then we want to do a number. So what we'll do is integer current health, and we'll get another integer, which is going to be the maximum health. So we'll just put current plus current health here, put the dash plus maximum health. Later on, we'll replace this system for something slightly different, but it's going to be okay for now. There we go, like this. Next, we will do a level display.text is equal to level, and we will just take in a string level or current level, like so. So we'll just do this plus current level. And finally, for updating points, we'll take int points, and we'll just do point display.text is equal to points plus, well, space plus points, like so. And we have all of these done. So this will update the UI text component that displays current player health. Here we'll have the current game level. And finally, here we will do the that displays current player player points, like so. With this, we have everything set up. We just have to attach everything to itself. So canvas player data, and let's attach every single text. So player points into the points, current level into the level, and finally health into health. Just gonna delete these. So with all of that setup done, let's start creating things that will allow us to use these. So handles all the UI changes. Let's remove this like so. Now let's create let's start off by changing the player health. So we can move around. Let's just quickly kill off our character by making the falling. So this is what happens when we fall, right? Well, currently nothing happens, but what we actually want to do is we want to have something that controls collision in the out of bounds. So let's remove the box collider and attach a 2D box collider to each of these. There you go. And we have an out of bounds script. So let's add the script to both of them, and let's set both of them as trigger. Now that we have this, let's remove all of that and check if our player has anything that we can use to identify the player with. So if we click on our player character, we can find that there is a player tag that is default with the game, and we have a rigid body. That means that we can use triggers to determine. So we'll do private void on collision, actually on trigger enter, and we'll just do if collision dot tag is equal to player. Then we'll for now just do debug.log player has collided with the collision object as a quick test. And let's just type in here handles player moving out of bounds. Determines whenever another collider has entered this collider. Let's give it a play. Now, while I test this, just a quick thing that I'll do. I'll be posting some extra videos. Yeah, the movement really needs a change. I'll be posting some videos onto the YouTube. There we go. Which will show different types of movement within the game. So there's a few things that we want to do here. First, we want to signify the player has lost. We want to remove from UI health, start the respawn function from the checkpoint. So we need some kind of a checkpoint in the game, which is, if I remember, Mario only has the default position, which is the start position of that specific level. So we need a level manager script that we should add. So let's actually create a new game object and let's call it round manager. So round manager will be only, or actually level manager will sound better. Level manager. This will have all of our level specific components. In fact, we can even just copy this component, remove it, and move that into level manager. It just makes more sense for it to be here. Let's reset this to 0 and let's create a new script called level manager, like so. Now inside of here, we will have a serializable field, which will be private string level name. And this can now be removed from here. And what's going to happen here is on start, we will also, before this, we will have a reference to our UI manager, private UI manager. So manager UI is going to be equal to this dot, no, game object, no, this dot game object dot component UI manager, like so. And then we'll just do manager UI dot, what is it called, update game level, and we will pass through our level name, like so. So this solves our first UI issue. Now, this, what else do, if we go into this, so first player has lost and we have to remove from the UI. So our health will be stored in our game manager. So let's just set this to 3, like so. And let's add a function which will be called public void remove health or lose a health. And let's call it from our out of bounds. So let's do a game manager dot instance dot lose a health, like so. Now, when we run lose a health, we will do health minus equals, no, just minus minus, like so. In here, we'll actually also add private constant max health, and we're going to make it equal to 3. So we'll always have 3 health, never more. And then what we can do is when we instantiate the game for the first time, we'll just set health to max health. But for now, we'll leave it as this. Now we'll do if health is smaller than or equal to 0, then health is equal to 0. And then here we'll have game over trigger. And afterwards, we will run our UI manager.update health. So what we'll do is, where are we? We'll create an instance of the UI manager so it's easier to grab it. So we'll just do public static instance, public static UI manager. This is going to be awake. And we'll just do instance is equal to this. Now we will not create a don't destroy unload, and we will not be passing this through to the other object. We just want to have a quick way to be able to access this from our game manager, as we don't want to have any connections in the game manager because those connections will be severed when we move to another scene. So let's create a UI manager dot instance dot, and that will be update player health, and we'll be passing through our current health and maximum health. Health and maximum health, like so. And now we officially update health properly. Now that we have this, we will also want to update health at the start of the game. Now, the reason why we put this in start is because our instance gets assigned in awake, and awake gets called before update. So we want to first assign all of our instances in awake, and then in start, we will just call in this instant grabbing. Okay, this might actually have to be changed to on enable, but it's okay. So the deals with losing a health point. Now let's go back into our out of bounds. So now we have this, both of these, but now we have to respawn from the checkpoint, right? So let's create a serializable field, and we'll just call it private transform, and this transform player start position. And let's actually get a reference to our player. So let's just do private game object. And this is going to be our player object, like so. And what's going to happen is our player object.transform.position is going to be equal to our player.startPosition, player start position transform.position. This might change now, so let's create this in a separate function, and let's call it private void reset player position. And there will be a slight issue with this. Might be actually player object dot set active false. So sometimes there is an issue when you move between colliders. I'm just going to disable the object when we hit the bounds. I'll move the object and then we will set it to true later. I think there's going to be a slight delay between performing this specific action, but for now we're just going to leave it as this, because we will probably want to add some kind of a lost sub animation delay, maybe an I enumerator or something like this. But this is good enough for now. Now let's go into our level manager, add our level manager script. This specific name is going to be 1/1. Since we're starting the game here, might as well make this our start position. So start position, like so. Hey, where are we? Let's attach a symbol to it so we can actually see where it is. Where are we? There we go. So we see a little thing like this. So -4 is good. Now let's attach our start position here, and let's attach our player object to here. And now let's give this a try. And let's fall. Player has collided. Now we of course didn't call our respawn, so that's something that we do have to do. So let's make a private level manager manage level. And what we'll do here is, if our manage level is equal to null, then we'll just grab the reference. So manage level dot get component. No, so we'll just do manage level is equal to game object dot find, and we'll look for level manager. We could set this as a start function. However, a player may never collide with, may never fall out of bounds. That means that we'll never call this function at all within the code, which means that we can technically save some minimal performance if we never collide. So there's no need to run it. Basically, what I'm saying is there's no need to call something that might not happen. So we'll just do this check here once in case we do. And then we'll just do level manager dot, and we'll have to set this to public. And we'll call this at the start as well. So reset player position, like so. And in our reset player position, like so. Now with this, we now have the respawn function complete. So we can fall out of bounds and the game will do as it should. Now, yeah, the movement really has to be changed. I'll figure something out. I'll try working on something that's fun to play with. There we go. So we have collided with the object. However, we did not respawn. So we need to slightly change how the respawn mechanic works. I think the best way to do it is just handle it in the coroutine. Where's our player? Oh, that's right. So what happens is our camera script never moves back. So what really has to happen is we need to reset the camera to start position. So we'll just do a private vector free, a start position, like so. And what we'll do is we'll do start position is equal to player object. Now let's just do this and see what our start position will be real quick. So our camera by default is, let me just take a screenshot of that so I don't get confused. And let's run the game with this code. Where are we? Main camera. So one, because camera has to be slightly higher. So now let's just do not bother with that. So position is equal to this dot transformed. So we'll just default it to this position on the start. And what will happen is you will have to reset the camera to this position as well. So if we go into our out of bounds, we will just get our camera as well. So we'll do private, what's it called, camera movement, camera reset, or should we just do it now? Since we're already running our reset player position and camera is part of the player options, we should have a reference to our privates, to our camera script from here. So we'll do camera movement, camera move, and we'll just do camera move is equal to camera dot main dot get component, get component, and we'll do camera movement like so. And here we'll also set our camera movement dot actually, so we'll change this out slightly. So we'll assign this in awake. So this happened before we run this in start for the first time. And let's just do a new function called public void reset position. And reset position is going to be this dot transform dot position is equal to start position, like so. We might actually store this slightly differently later, but for now, let's leave it as this. It's good enough to do what we need it to do. Let's press play and see how that's going to work. There we go. And we do reset properly back to our original position, which is exactly what we want. Now, with this done, let's add in our enemy. Actually, no. Yeah, let's add enemy and then let's work on adding points. For now, we might just create the code and then later might work on the other elements. So I was thinking about, let's just do an enemy first and then we can think about the other things. So let's start off by creating a new variable and we're going to call it float speed. And let's set that up to a 1. We'll have a rigid body. (2D), and that's going to be just RRB. we'll have a distance for our array. Now I tested this previously and I'll be using 0.6. This is something that you kind of want to test depending on how you handle this. And we'll just call a ground mask and set that to 0 by default. And we'll make 2 more fields. First one's going to be boolean, and then is right. I'm going to set it to false, and finally private vector 2, and we're going to call this a direction. Now in start we will set our isRight to false. We're going to call a function like this, which doesn't exist yet, and rigid body is going to be equal to this.gameObject.getComponent rigid body 2D. Now something that we do want to do is make sure that we do require component type of rigid body 2D, because this code will not work without our rigid body. Now let's create an update, and let's create a function called flip so we don't get any errors. Now let's create an update and fix update. So first we'll create our update, and here we'll just call a raycast. So we'll do raycast hit 2D. Hit is equal to physics 2D dot raycast transform dot position direction ray distance and ground mask. So this will just throw a ray in the direction that we want it to throw with the height that we want it to be using the mask that we provided. Then we'll do hit.collider, and so if basically we didn't hit, if we collided with something, we'll just call our flip. So that will allow our enemy to move backwards and forwards. Let's create private void fix update now to handle our physics. And this is going to be a very primitive function where we're just going to do rigid body dot velocity is equal to new vector. And we're just going to do 0, 0. And then we're going to do if is right. Then what's going to happen is rb.velocity is equal to new vector. Wait. And we're going to set the speed at 0. And then we're just going to create the same thing as an else, but instead we'll do a minus speed. Very simple. And in our flip, we will just do isRight is equal to isRight. So this will keep switching the isRight to opposite of what it was previously. And we'll use quaternion.ruler to rotate our enemy, like so. And then we'll just do isRight, and we'll just do direction is equal to new vector 2. And we'll be manually assigning our direction. So if someone remembers the graph that I showed, this means right. And if we do this the opposite way with adding a minus, the answer is going to be left. As simple as that. Now, with this, we have the entire script done. I don't know why this got added here. Now, we're going to test this later as we are running out of time. But we'll definitely add coins. Now, I'll have a quick 2, 3, maybe 5 minutes break for toilet. And then I'll return with the final edition. Okay, I'm back. Sorry for the wait. Now, let's create our little coins for our game for now. That we can move in. Actually, let's add in the enemy and add the coins and add the adding of points. So first, let's start off by creating a cylinder. All we're gonna do is make this. Well, let's close Steam for a while. And what I'm gonna do is, now that I have this coin, I'm gonna rotate it so it's standing up. There you go. And I'm just quickly gonna Google what a Mario coins look like. Let's have a look. Images. Okay, so they're not exactly. They're more like this, and they're about the size of this small one. So if we just move this down, maybe a little bit smaller. Like this? Yeah, sure. Let's attach a temporary material to it for now. Oh wow. Let's call this the coin. We will create something, a kind of visual for it later. Now we want our coin, of course, to have a 2D. Let's just give it a capsule collider. How big is the collider? Okay, like this, maybe can stretch it out a little bit. There we go, like this. I'm gonna set this to 0, 0, 0. And let's move it up. Now, what we now want to do is we want to keep spinning it like this. So we want to spin it on a Z constantly. So we'll do this by adding a script to it, which we'll call rotator. And right now, our project is starting to get a little bit messy. So let's create some folders. Game management, management. There we go. Sorry, I had to switch off my English brain and try to figure it out in Polish. So we'll have game management, we will have utilities, and we will have physics. So anything that uses physics, we'll just place in one place. Okay, so now like for our game management, we'll put this in. Our UI and level manager will be here too. For our physics, just going to put rotator is going to go into utilities. And camera is, well, camera technically doesn't use physics, so it's just going to be here. By physics, I mean anything that uses rigid bodies, which this project will be heavily reliant on. Okay, and the rest can just stay for now. Now let's add our rotator here. Open up the script. Remove this. Just create a brand new update, and we'll just do this dot transform dot rotation is equal to new vector 3, and we're gonna do 0, 0, 0. Can I just do this dot transform dot rotate? We can. So let's just do 0, 0, 0 for now, and we're gonna do private float rotation rate. Let's set that up to a 20 and replace our Z with 20 times time delta time, like so. And that should be good enough to make our coin rotate. Now, there we go. It rotates nicely, if I say so myself. I feel like it should rotate the other way around. Let's do this. Let's add a minus. Change this to 35, so it's slightly faster. Yeah, that looks good to me. Okay, now let's rename this as a coin. Of course, the whole purpose of this is for it to be collected by our player. So we need another script which will be called coin. Let's just call it our coin. Let's drag our coin here. And we'll, of course, have, just like in out of bounds, we'll have a function like this. So we'll just remove all of these default functions, push that one in. And if we do collide with our player, then what we want to do is we want to have a connection. Well, we want to add points to our game. So let's open up our game manager. And apart from loose health, we will have public void add points. Now, we'll be sending over int point amount, and the coin will have a value of points. So private integer value, or let's just call it point value so it makes more sense. And what we'll do is we'll do game manager dot instance dot add points, and we'll pass in point value through. We then, of course, want to set this dot game object to as inactive. So we want to disable this object entirely for till the end of this round, like so. And that's all this really needs to do as a script. And what we'll have here is we'll just do points plus equals point amount, and then we need to update the UI. So we'll just call this, but of course, instead of update player health, we'll do update points gained, and we will send in our points through like so. So let's give this a try and see how it's going to work. So let's put some coins along the way and see if we can collect them. Oh, let's give them a value of 10 per coin. So as we see, each of these, oh, for some reason we collided with them very quickly. How big is the collider on our player? It's quite small. How big is the collider on each coin? I'm surprised we collided so quickly. I feel like the collision is slightly too big, but where is the collision being so big? Is it because of this? Can't be, right? Let's slimmer down the collision on each of these, and while we're at it, let's add our coins to our prefab, as this is something that we'll want to create a lot of. Let's see if there's going to be a difference now. No, why are they being... That's so weird. It's like we have an extra set of collisions somewhere. Where are we? Well, I can see that there is a change in how we collide, because now our object goes inside, so the collision was correct on the player. We need it like this, definitely. But why is the collision so off on the... There we go, see? Weird. Okay, let's remove the capsule collider, and let's add a different type of collider. Let's just add a box collider for the sake of testing it. Oh, we didn't do in trigger. Okay, that's so weird. Why are you not picking up the collision? Oh, the coin doesn't have a tag anymore. Wait, it doesn't have to have a tag. That's strange. ebook.log collision. Oh, no, because we added a typical box collider, whereas we're dealing with 2D colliders. 2D box collider. There we go. Where are we? Like this. There we go. Let's give this a try. Oh, that's interesting. So it's almost as I know what's happening. Let's duplicate this coin. Now let's go into the other one. Now let's remove the coin script. Let's remove the collision. Now let's go back to this one. Remove the mesh. Remove the rotation. Remove this as well. And now let's apply this. Interesting. Will you not let me? Oh. Let's unpack this. So then coin visual. So we have rotation, we have our mesh, and then that's it. And this one will only have the coin. Yep, should be fine now. There we go. So what was happening was the collision was actually moving this entire time, and of course that's not something that we wanted to happen. There we go. As you see, now it's better. Of course, what's not better is the size of the coin. So let's click on our little coin. In our scene view, disable the 2D real quick. Right. Open. Okay. We made a mistake. 90,000. What? Okay, so the biggest problem with this is now that if we attach it to that, it will change everything. So let's actually remove this entirely, create a new game object, reset the position, place this at 0, 0, 0. Okay, drag that guy in. Better. I kind of think it's too thick. No, wrong way around. Okay. Thinner it. So what's gonna happen if we now flip it? Okay, so that should be fine now. It should no longer give us any issues. So we'll just add a coin to it, and we'll add a 2D box collision. We'll adjust the collision a little bit. Actually, let's put it at 0. And now look at this collider, make it smaller. I kind of want to make it a little bit smaller than the actual object, so we do walk into it. And with this done, just call it coin, add 10 to it, and let's create a few of these and give it a go. Oh yeah, it's not gonna work. They need to be set on trigger. Where are we? Yep, and now it feels like we are properly collecting it. What happens if we fall? We will reset it to the position. We could create some kind of a smooth walk into the position and then enabling the character or something like that. But I think it's fine for now. With this done, I just realized that this guy's not. Oh yeah, because the camera gets moved to a in position later on, doesn't it? No, it stays here. I guess it's because it's 2D, so it doesn't take Z on the calculation. So what do we have? We have this, we have this. I guess this is it for today. So we have our, actually, since we have about 5 more minutes, there's something with the level that I don't really like. And that is, I believe, not this bit, this bit. So this bit's too long. This should finish here. So need to remove the top 2. So 1, 2. Also, the flag. Why is the flag so off? I thought they were like properly adjusted, these guys. Wait, what? 0. That's fine. That's definitely meant to be at the 0. There we go. This so much bothers me. Whatever. Okay, so let's give this a upgraded little jumpy a try. Ah, okay, it's slightly wrong. And there we go. We have our flag. Flag is way too big as well. Flag has to be level with this. Okay, so let's fix this a little bit. And then the flag has to get smaller, essentially. There we go, like this. Should be fine. Perfect. Okay, with this, oh, these guys can be. See, I never realized this because I keep doing this in the 2D view. It's not like it matters, but it just bothered me personally. Okay, so with this done, let's go and actually fix the cylinder towers and create a prefab out of them. I feel like this might be one of the next few things that we'll be working on. So let's remove that and add a 2D box collider. Perfect. So, and then we'll do the same for the top. So 2D box collider. The reason why we want a 2D box collider to be here is because this is where we will enter the tower from. Okay, and now that this is done, we can add this as another prefab. And that'll be it for today. We made significant progress. Something that I would like to add is that I'll be making short YouTube videos on how to do individual mechanics that I usually show in here, because I believe that 1 hour sessions are too big to pick up individual elements if someone wants to learn. So I'll be breaking down all of these into small little segments that are easier to read and understand. And that'll be it for today.